All right, we just did a hypothesis test about a proportion, and now let's look at one about a mean. I can see that this is a two-tailed test because of the not equal in the alternative. I am testing this 76.6. So this is my claim. This is my significance level. And it says you believe the population is normally distributed, but you do not know the standard deviation. So that right there says this is a t-test. We have a sample size, n equals 118. We have our sample mean and our sample standard deviation. So what we want to do is figure out this 76.1. We want to standardize our mean to 0. And then we want to know what that t-value is and what the probability, the p-value that we would expect to get a value that far away from the mean. So opening up my Google Sheets, this is a t-distribution. They give me a mean of 76.1. A standard deviation of 7.4, a sample size of 118. What I'm testing, the null was 76.6. Don't forget to change this to not equal, and I get my test statistic and I get my p-value. So let's go back here. So I get a test statistic of negative, that's too fat, of negative 0.73. That's this value, negative 0.73. Makes sense it's a negative because it's less than 0. And then my p-value, the probability that I would expect to get this value if the mean is true, is huge, right? This is a big p-value. This is a good probability. This probability is definitely greater than alpha, because it's greater than 0.001. When the p-value is greater than your level of significance, then you fail to reject the null. And then in this case, there is not sufficient sample evidence to support the claim that the population mean, this is our alternative, is not equal to 76.6.